So, as I was saying, we're going to be looking at, I'm just going to give a brief overview of the different types of reactions that most reactions that you're going to encounter in this course will fall under. So the first type, as soon as I can turn my pen on, the first type is, and this is not necessarily going to be in the same order as discussed in the videos. So the first type I'm going to talk about is decomposition. And in the case of decomposition, what they all have in common is that you're starting off with one reactant and you're going to end up with more than one product. So for example, if you heat calcium carbonate, and most of these decomposition reactions require heat. All right, so if you heat calcium carbonate, you're going to get calcium oxide plus carbon dioxide. All right, or if you heat PCl5, phosphorus pentachloride, you're going to get PCl3 plus Cl2. All right. So in both of those cases, you can see clearly you're starting off with one reactant and you're ending up with more than one product. All right. So that's decomposition. The next one I'm not going to use over here is combination. And combination is basically the reverse of decomposition. In other words, you're going to start off with more than one substances and they come together to form one product. So for example, hydrogen plus oxygen to give water. That's an example of a combination reaction. All right. Or I can think of another example. Nitrogen plus hydrogen to give ammonia. That's another example of a combination reaction. All right. So combination reaction involves two or more substances coming together to form one product. All right. The fourth type of reaction we're going to look at is, I'm going to mention here, is single displacement. I'll clear this here. Single displacement. All right. And basically what happens in a single displacement reaction is that you have one substance, it could be an element or a group of atoms, reacting with another substance, which is a combination of two parts, could be two elements, whatever. And what happens is that this here replaces this, and then you end up with a compound formed between A and C, and B is displaced, right? So this is called a single displacement reaction. In some textbooks, they call this a single replacement reaction. So if you see that terminology, it's the same thing, all right? So to give you an example or two, if you take magnesium, if you take a piece of magnesium and you put it in a solution of copper 2 sulfate, you're going to actually see a visual change, right? But the reaction that is taking place is this right here, where the magnesium is going to replace the sulfate and the copper will be displaced. The visual change that you're going to see is that this solution here is blue in color. And then if you put the magnesium in it and then you wait for a while, then what you're going to see is that the blue color will become lighter and lighter until if you add enough magnesium, it will become colorless. And that's because the resulting solution will now contain magnesium sulfate, which is a colorless solution. Another thing you'll notice in this reaction is a solid deposit, and that would be the copper that is formed, right? So those are the two things that you would observe in this particular case. And this is an example of what we call a single displacement or single replacement reaction. Another example of a single replacement reaction is the reaction between, if I remember correctly, it's chlorine plus sodium iodide to form sodium chloride plus iodine. And to balance this, we're going to need a 2 here and a 2 here, right? So in this case, you can clearly see that the chlorine is replacing the iodine, and therefore you end up with the products being formed. One of them is sodium chloride, and the other one is the iodine, which is displaced, right? So that's basically what happens in a single displacement or single replacement reaction, all right? Then we have what is called a, oh, before we do that, now there's one aspect that was discussed in the videos, and it has to do with how can you predict whether or not a single displacement reaction will take place. And that's important because of one of the questions that we're going to encounter in the assignment. So let me clear this. And in fact, let me go here. I need to show you a chart, which you would have to, I'd have to provide for you in your future test. It's called the activity series. So let me go here. Tables. Activity series. You don't know this. Now there are two activity series, in fact. As soon as I can get this downloaded. Oh, it's not. Oh. Okay, so there are two activity series, all right? One of them is a list of metals placed in order of, in this case, decreasing activities. Different textbooks, you see them put in order of increasing or decreasing activity. Basically indicating which one is more reactive than which, all right? So in this particular case, we have a group of metals here. There's one, yes, make sure you get one of them. There's one exception here. There's a hydrogen, which is not a metal, right? But we have a list of metals here, okay? And they're ordered in terms of decreasing activity. So basically what this is telling you is that lithium is more reactive than potassium, which is more reactive than calcium, and so on. So this is what you're going to need in order to make predictions as to whether or not a particular single displacement reaction will take place, all right? Because the fact that you can write down an equation doesn't necessarily mean that the reaction will take place. So I'm going to use this to illustrate how you can make predictions. I'm just going to make up an example. Let me open this up. No, not that. This one. Series. So let's say I gave you okay, let's say I gave you this equation. NiCl2. I want to give a good example. Okay, let me change that a bit. So let's say I gave you Ni plus potassium chloride to give NiCl2 plus potassium, and to balance this, I'm going to need a 2 here and a 2 here. So let's say I gave you this equation, and my question to you is, will this reaction take place, right? So what you'd have to do is consult the table. And if you look at the table, you'll see that nickel is down here and potassium is up here. So basically, remember now, it's in order of decreasing activity going down. So what that tells us is that potassium is more reactive than nickel. So based on that, we can conclude that this reaction will not take place. So no reaction. And the reason why is because nickel is not reactive or not more reactive than potassium, and therefore nickel will not displace potassium to form the products here. So therefore no reaction will take place because potassium is more reactive or more active than nickel. Now the reverse will definitely take place, right? The reverse reaction is the one that's more likely to occur because potassium will displace nickel from nickel chloride to form the product because potassium is above nickel in that series, all right? Let me give another example. Let's say you're given magnesium plus zinc sulfate to give magnesium sulfate and zinc. Again, the question is, will this reaction take place? Again, we have to consult the table to see where magnesium and zinc are relative to each other. So if you go to the table, you see that magnesium is here and zinc is 2 places down. So that tells us that magnesium is more active than zinc. So therefore, we can conclude that this reaction will take place. Magnesium will actually displace zinc to form magnesium sulfate. So therefore, this reaction will occur because magnesium is more active than zinc. All right. Okay, so in order for you to answer questions like these, I would have to provide you that chart. Yes, sir.
Can you go back to that chart real quick?
That's this right here.
Yeah. So I thought we wouldn't have a reaction because potassium has more activity than nickel.
Yes, potassium, right. So the first reaction, let me show you.
But so why does
The first reaction is this reaction right here,
yeah.
right? So because potassium is more active than nickel, nickel will not displace potassium.
Oh, so it matters what comes first?
It matters what is being displaced.
What does it matter which one is first?
No.
Because the magnesium has more reaction than the zinc.
Right. Magnesium is more active than zinc, so therefore the magnesium will displace zinc.
So it has to be in front for, let's say zinc was in front of magnesium, there would be no reaction then?
You're talking about the series?
Yeah, the series.
Right. If it was the other way around, then of course this reaction would not take place.
Okay.
Right. It's a matter of which of the metals are more active.
Yeah.
Right? The one that's more active will displace the one that's less active from its compounds. That's basically what it comes out. All right. Okay. Now there's another activity series which is to the right of the table that I just showed you. And this is an easier one to deal with because it's basically dealing with the halogens, right? And basically, as you go down that group, which is group 7, what you'll find is that the activity decreases, right? So fluorine would be the most active, followed by chlorine, then bromine, and iodine. And based on that series, we can make predictions where these halogens are involved. So let me go back to this, and let me, there it is. Bless you.
Nice.
So let's say you're given, let's say you're given fluorine plus sodium bromide. All right, to give you sodium fluoride and bromine. And the question is, oh, we have to balance this, of course. So 2 here, 2 here. And let's say you're asked, will this reaction occur? Well, the answer is yes, because fluorine is more active than bromine, and therefore will displace it. So therefore the answer is reaction will occur. All right. On the other hand, if I gave you this equation, I2 plus potassium chloride to give potassium iodide plus Cl2. And again, to balance this, put a 2 here, put a 2 here. Will this reaction occur? No. Reaction will not occur. Why? Because Cl is more active than I, and therefore Cl will not displace iodine from its compounds. All right, so that's just a shorter activity series involving the halogens. All right, so that's basically a kind of side discussion that we had in the videos concerning single displacement reaction. All right, so let me what was I saying? Okay, so I covered combination, decomposition, and single displacement. So the next type of reaction I'm going to talk about is double displacement. So in the case of double displacement reaction, this typically takes place between 2 ionic compounds in solution. All right. So let me just give an example to illustrate what a double displacement reaction is all about. So let me turn on my pen here. So the example I'm going to use is sodium chloride, aqueous, plus silver nitrate, aqueous, to give AgCl, which turns out to be a solid, plus sodium nitrate, which is in an aqueous solution, right? So we call this a double displacement reaction because you'll notice as you go from reactants to products, there's an exchange of ions between the two compounds. So what happens, for example, is that the sodium will displace the silver from the silver nitrate, and at the same time, the silver nitrate, or the silver, I should say, displace the sodium from the sodium chloride, right? And the result will be the two products that are formed, one of which will be a solid, right? So if you were to actually carry out this reaction, let's say you had two test tubes. One contains the sodium chloride, the other one contains the silver nitrate. Two clear solutions, two clear colorless solutions. You mix them together, you get the spontaneous formation of a white solid, which would be the silver chloride. And there's a name given to these reactions where you mix two solutions and you end up with a white solid. We call these precipitation reactions. Precipitation reactions, all right? And the solid that is formed is called a precipitate, right? A precipitate is a solid formed as a result of two solutions reacting with each other, right? And a precipitation reaction is one where you have a solid form when two solutions are reacting, all right? So that's basically what happens in this particular type of reaction. Just to give another example of a double displacement reaction, let's say you're given potassium iodide plus lead nitrate, PbNO3, 2, all right? To give PbI2 plus potassium nitrate, all right? And to balance this, we're gonna need a 2 here and a 2 here, right? Now these two on the reactant side, these are both aqueous solution, and it turns out that the lead 2 iodide is a solid, and this would be an aqueous solution. And in this particular case, if I remember correctly, this has a yellow color. In fact, I think I remember seeing that video. Let me see if I can pull up that video. Let me see. Okay, so lead, 2 nitrate, and potassium iodide. Okay, so this is the lead 2 nitrate in an aqueous solution, and I think what's going to happen is that there you go. And you see the spontaneous formation of the yellow solid. That would be the lead iodide, which I have over here. All right. Okay, and that's the equation that I just had. Okay, so that's basically what happens in that particular case. All right, so let me go back to, where was it? Okay, now I want to give another example because sometimes things are not as straightforward as we would prefer. Let me clear this here. And this example I'm going to show you is a reaction between sodium bicarbonate, aqueous, and hydrochloric acid, aqueous.
What did you put in the parentheses?
I'm sorry?
What would you put at the bottom of CO?
You mean here?
Yeah, right there.
That's 3.
To the right of that,
Oh, aqueous, AQ.
AQ.
Yeah, that's the symbol, the state symbol for
Do you have that in
aqueous.
parentheses?
I'm sorry?
Do you have that in parentheses too?
Yeah.
Maybe.
Yeah. Now one would predict that a double displacement reaction will occur, which actually happens in this case, where the sodium displaces the hydrogen to form sodium chloride, which would be an aqueous solution, and the hydrogen will displace the sodium to form H2CO3. And this is also aqueous. But it turns out that in this particular case, the H2CO3 will also undergo a decomposition reaction to form H2O liquid and CO2 gas, right? So in this particular case, you're going to have firstly a double displacement reaction occurring, right? And then this product here will undergo a decomposition reaction, all right? Okay, so that's double displacement, all right? Now there's one more category of reaction that we need to discuss, and that is called combustion. And combustion reactions basically involves burning a substance, right? When you're burning anything, right, doesn't matter what it is, you're basically facilitating a reaction between that substance and the oxygen from the atmosphere, all right? So an example of a combustion reaction would be carbon, solid, plus oxygen, gas, to form carbon dioxide gas, right? Heat is required, and that's basically an example of a combustion reaction, right? Another example would be sulfur, 8, solid, plus O2, gas, to give sulfur trioxide gas. And to balance this, we need an 8 here, and we need an 8 here, 8 is 24, we need a 12 here, all right? So these are two examples of actual elements which when burnt in air produces, you know, oxides of the element. Now, also, when it comes to a group of compounds known as organic compounds, we can also have a situation where they can experience combustion as well, right? Now, what I'm going to do is limit my discussion. Well, firstly, let me just say this. I don't know if you know this, but organic compounds are basically compounds of carbon. Compounds of carbon. And there are some exceptions, right? Some minor exceptions to this particular definition, all right? But what I'm going to do is limit my discussion to two types of organic compounds. There's one type known as hydrocarbons, which are made up of carbon and hydrogen only. All right, so for example, gasoline is a mixture of hydrocarbons, right? It's a mixture of compounds which contain, and that's true for most petroleum products as well, right? So you have compounds like this which contains carbon and hydrogen only. And then you have other type of compounds which are not hydrocarbons, which contain carbon, hydrogen, and oxygen, right? So I'm going to limit my discussion when it comes to combustion of these compounds to hydrocarbons and organic compounds which contains carbon and hydrogen and oxygen, all right? So let me clear this here and talk about what happens when you burn these compounds. If you take your compound, let's say it's a hydrocarbon, it contains carbon and hydrogen, and you burn it in the air, you're going to get carbon dioxide and water, without exception, all right? If you burn it long enough, sufficiently enough, that's what you're going to end up with. And guess what? The same is true if your organic compound contains carbon, hydrogen, and oxygen. Same thing is going to happen. You're going to end up with CO2 and H2O, all right? So it doesn't matter if you start off with a hydrocarbon or if you start off with a compound which contains carbon, hydrogen, and oxygen. When you burn them completely, you're going to end up with carbon dioxide and water. So I'm going to give you a couple of examples. Methane, CH4, that's the simplest organic compound, right? When you burn it in air, as I said before, you're going to get CO2 and H2O, right? So all you have to do, once you determine what the products are, is balance it. And in this case, that means that you're going to need a 2 here, and you're going to need a 2 here, and that's it, right? And that balances that equation, all right? Let me give another example. Benzene, the formula of which is C6H6. Again, if you burn it in air, you're going to end up with what? CO2 and H2O, right? So to balance this, we need a 6 here, we need a 3 here. So 6 times 2, 12, plus 3, 15. So I'm going to put 15 over 2 here, and then I'll multiply everything by 2. And that gives you 2C6H6 plus 15O2 to give you 12 CO2 plus 6 H2. And that's it. All right. So basically, most, if not, well, most, I would say, of the reactions, as I said before, you're going to encounter in this assignment and also in any future assignments will fall under any one of these categories. All right. So with that said, let's move on now to the assignment. So let me clear this and scroll down. So this question in section A is asking for you to balance the following equations. So pretty much you're going to get some more practice in balancing equations, but it says also you're going to state whether each represent 4 categories or the 5 categories that we discussed: decomposition, combination, single displacement, double displacement, combustion, or other. So there may be some of these which won't fit into any of these categories. If that's the case, you just simply say other. All right. So let's start off with the first one. Let's balance it firstly. Let's balance it. So how do we go about balancing this equation?
Either add a 2 before the AI and then the AIN.
Well, it's actually AL, but
Oh, it's an L.
you're right, yeah.
So,
But you're right, you're right. So a 2 here and a 2 here, right?
yeah.
Okay, so what type of reaction would you put this, what category of reaction would you put this on?
That'd be a sin.
Is that a combination?
Combination. Combination. Remember combination, 2 or more substances coming together to form one product, all right? What about the next one? Well, let's balance it first again.
Me too.
3 and 2 here, right?
Yeah.
No, wait a minute.
Not like from the O2.
Yeah. My bad. Okay, and what type of reaction would this be? Combination, or you can also say this is combustion because so combustion. Oops. Because you're burning iron in this case and oxygen, all right? So sorry?
O2 mean you're burning.
Hmm?
You have O2 instead of the equation, doesn't mean.
Right, exactly. It's reacting with oxygen from the atmosphere. So yeah, so you can, both of these are just as correct, all right? Combination or combustion. Okay. Okay, let's talk about balancing number 3.
The 2 and 3.
Nope. It's already balanced. Exactly, 1 over 1, exactly. So what type of reaction is this? Decomposition is correct.
What else would be combustions?
No, because you're not reacting the calcium carbonate with water. I mean with oxygen, I'm sorry.
What makes it a decomposition?
Because you're starting off with one reactant and you're ending up with more than one product. So it's kind of like the reverse of combination. Combination, you're putting 2 or 3 substances together to form one product, but in the case of decomposition, it's the reverse. You're starting off with one substance and you're going to end up with more than one product. Okay, number 4. Let's balance it first. So how would you go about balancing this? Hold on, show that, hold on. Wait, what did you just say?
2, 1, 2, 1.
For number 4?
Oh, sorry.
Oh, you're skipped down to number 5. No, we're dealing with number 4 now.
1, 1, 2.
1. No, I wouldn't say that because. Oh, wait a minute. 1, 1, 2. Oh, yeah, you're right. You're right. Okay, good. Okay, so what type of reaction is this? Decomposition again, exactly. Okay, so now we get to number 5, and you were saying number 5 is what?
2, 1.
2, 1, 2, 1. That's correct. What type of reaction is this?
Single displacement.
Single displacement is correct. Okay, let's balance this one. How would you go about balancing this one?
One, two, 1, 2.
1, 2, 1, 2. And what type of reaction are we talking about here?
Double this.
Double displacement is correct. Double displacement. Okay, let me clear this here. And scroll down. Okay, let's balance number 7.
Two, 2, 1.
2, 2, 1 would be correct. And what type of reaction is this? Decomposition. Okay, very good. Number 8.
2, 3, 1, 3.
2, 3, 1, 3. Okay, yes, I will go with that. And what type of reaction would you put this? Double, nope.
Single.
Will be single displacement. You see why?
Oh.
Exactly. There's no exchange. Basically, this is displacing the hydrogen. All right. Number 9. Let's balance this one. How would you go about balancing this one? Number 9. 1, 2, 1, 2. And what type of reaction is this? Double displacement is correct.
Can you explain to me again how you know it's a double or a single?
Okay, so in the case of a single displacement, you have one atom here or one type of element displacing another element from the compound here, and therefore you end up with the products. In the case of double displacement, you have an exchange of ions, right? So the magnesium will displace the sodium, but at the same time, the sodium will displace the magnesium. And that's how you end up with these two products. All right? Okay, okay, so number 10, let's balance this one. How will you balance number 10?
2, 1, 2, 1.
2, 1, 2, 1. Okay, and what type of reaction is this?
A double displacement.
Double displacement. All right. So what I'm going to do is leave the rest for you to do because I want to get to the other sections before time runs out. So let me clear this and scroll down to the B section. Now, in the case of the B section, what they have done is that they have described reactions in words. And then what you have to do is figure out the equation, right? So several things will come into play. So firstly, well, one of the things that you'd have to know to do is to figure out what the formula for the different substances as described in each of these questions. And then once you figure out what the formulas are, you have to figure out what would be the reactant and what would be the product. And then based on the reaction, which should be balanced, the equation should be balanced, you can determine what type of reaction we're talking about here. All right. So in the case of the first one, it says elemental boron is produced in one industrial process by heating diboron trioxide, and it gives you the formula, with magnesium metal. And then it says magnesium oxide is also produced as a byproduct of this reaction. So my question to you is this: what would be the two reactants involved in this as described here? Yes, sir.
B2O3
B2O3 will be one of them. And what's the other one?
plus Mg
I'm sorry?
plus Mg.
Mg, exactly. Very good. So those are the reactants and those are the formulas for the reactants. And then on the product side, what is present on the product side?
B2
B2, no, not B2, just B. Right? Boron exists, oops, as B. Did I, by the way, Did I tell you guys which elements exist as diatomics?
Mhm.
Okay, good. I just want to make sure, right? Just to remind you, those would be nitrogen, oxygen, fluorine, chlorine, bromine, iodine, exist as diatomic molecules. And then sulfur exists as S8 and phosphorus exists as P4. You need to remember those, right? Because it could be given, in fact, I think one of the questions later on deals with one of them. So when we get to it. Okay, but boron exists as simply B. And what's the other product based on the information provided?
MgO.
MgO, okay. So now we have to balance it. So how would we go about balancing this equation?
1, 3, 1, 3.
1, 3, 1, 3, B2. No, something is wrong here. Just cover
I
that.
forgot the 2 up there.
Boron should be 2, that's for sure. Magnesium would be 3 because, okay, right. So that's it. Okay. And what type of reaction is this?
Single displacement.
Single displacement. Very good. Okay, very good. The next one, it says acetylene gas is produced by treating calcium carbide, and it gives you the formulas for both of them, with water. And then it says calcium hydroxide is also produced as a byproduct of this reaction. Okay, so based on the information provided, what will be the reactants in this case? Based on the information provided.
CaC2.
CaC2 is one of the reactants. And what's the other reactant?
H2O.
H2O. And then what will be the products?
C2H2.
C2H2. Anything else?
Potassium hydroxide.
CaOH. What? 2, exactly. So now we have established what the formulas for the reactants and products are. We now have to balance this equation. So how would we go about balancing this equation?
1, 2, 1, 1.
Yeah. Okay, very good. And what type of reaction is this?
Double displacement.
Double displacement. Very good. Okay, any questions about this one? Any questions? Questions? All right, let me clear this. Scroll down. So it says nitrous oxide, also known as lactic acid, is used by some dentists as an anesthetic. Nitrous oxide and water vapor as a product can be produced in small quantities in the lab by careful heating of ammonium nitrate. Okay, so what would be the reactant or reactants in this case?
NH4NO3.
NH4, NO3, and then the products would be what?
N2O.
N2O plus
H2O.
H2O. So to balance this, what do we need to do?
1, 1, 2.
1, 1, 2, okay. And what type of reaction is this?
Decom.
Decomposition. Okay, so basically that's how you do all the questions in section B. Here it is there. So let me scroll down. So I'm gonna leave the rest for you to do on your own. Again, if you have any issues, let me know. Because I want to get to section C. Section C is where the table I showed you earlier comes into play. It says, predict the products of the following single replacement reactions at room temperature. So basically what they're asking for you to do is just tell what the products are. They're not even asking for you to balance the equation, right? They're just asking for you to tell what the products are, right? So the table that you're going to need is this table right here, right? So the first part, or the first question, they're giving you potassium and silver sulfide, right? So the question is, will this reaction take place? In other words, will potassium displace silver sulfide? So if you go to the table, you see potassium is here, and silver is further down, right? So basically, what would be the answer in terms of the products that would be formed?
That would be K2 S.
Exactly.
plus AG.
Exactly, and that's it. All right, so you don't even need to worry about balancing the equation because the question is just asking for you to write down what the products are. Okay, very good. Number 2, bromine plus sodium chloride. Will that produce a product?
No.
No. Why? Because
More active.
chlorine is more active than bromine. So therefore, bromine will not displace chlorine. So therefore, no reaction. All right. Okay. What about lead and nickel 2 chloride? So let me go to the table here. Where is lead? Oh, right above hydrogen. And what's the other element? Nickel. Okay, nickel is above lead. So if nickel is above lead, what does that mean? No reaction, exactly. So no reaction here. Okay, very good. Let me clear this. Scroll down. Okay, aluminum and tin. So let me go here. Where's aluminum? Okay, aluminum is here and tin is below aluminum, all right? So that means that aluminum is more active than tin. So will this reaction take place?
Yes.
Okay, so what would be the product of that reaction?
Aluminum oxide and tin.
Okay, and what would be the formula for what am I doing? What would be the formula for aluminum oxide?
Al2O3.
Al2O3 and tin. And that's it. All right. Okay, the next one, fluorine reacting with potassium iodide. Will that reaction actually take place? F2 plus Ki. It
Yeah.
will take place because fluorine is above potassium iodide. So what will be the formulas for the product of that reaction?
KF plus I2.
KF plus, KF plus I2. All right. Okay, the next one, silver and lead 2 bromide. So let me go to the table. Silver, where's silver? Silver, okay. Silver and lead. Okay, so that means that lead is more active than silver. So if lead is more active than silver, will this reaction take place? Nope. So I'm gonna put NR here. Okay, the next one. Magnesium and copper 2 nitrate. So let's go to the chart again. Okay, so magnesium, where's magnesium? Okay, magnesium is here, and where's copper? Okay, so magnesium is more active than copper, right? So will that reaction take place?
Yep.
Yep.
Okay, so what would be the products of that reaction?
Mg,
Mg,
NO3,
NO3 2, plus
C.
Cu, all right? All right, okay, let me clear this here. Let's go down. Okay, sodium plus potassium fluoride. So let's go to the chart again. Let's see, where is sodium? Okay, sodium is here and potassium is above sodium. That means that potassium is more active than sodium. So what does that mean for this reaction here? No reaction, exactly. So no reaction, all right? The next one, chlorine plus calcium fluoride. So chlorine is below fluorine, so what does that mean?
A reaction.
No reaction. Okay, the next one is lithium and potassium bromide. So let me go to the table here. So lithium is here, okay, so lithium is directly above potassium, which means that lithium is more reactive. So what does that mean for this here?
LIBR.
LIBR and
Okay.
potassium, and that's it. Because lithium is more active than potassium. Okay, oh, that's the end of that one? You realize, okay. So that's pretty much it for this one. In the time that we have left, I'm willing to hang around if you want to, work on the others. If you have any questions, But that's pretty much all for today. In the meantime, what I'm gonna do is I'm going to publish the videos for the next chapter 8. On those. Chapter 8.
By the night before practice, friends, nice and happy.
Okay, so I've just published the videos for chapter 8, and I keep forgetting to publish the files for the PowerPoints. So let me do that now.
Yeah, that's how I.
Oh, it's already,
Wait a second.
hold on. Oh, it's already published. Okay. All right, so make sure you watch those videos before next week. Yes, sir.
Don't have one that added, there.
Oh, so that's based on, remember the list of, no, the list of ions, right? So for example, in this case here, you know, it's aluminum and oxygen combining. Here's right here. So if you look at the chart with the ions, you're gonna see that the aluminum has a +2 charge and the oxide has a -2 charge. Then you have to make sure that the charges will cancel out, and the way you do that is that you multiply this by 2, and multiply this by 3, and then you put it together, it becomes 8L2O3.
So you just have to know the start.
No, you don't have to memorize it, because that's given in the table.
Yes.
Which you will have during your test. So you have to make sure you consult that table, right?
Yeah.
Yes, sir.
Essentially.
Number 12, section A,
Yes, sir.
number 12. Oh, okay, so for number 12, this is the one, right?
Yes.
Okay, so for number 12, you need to balance it first. So the balances, let's see here. You have 2 chlorines, I'm gonna put a 2 here. And that's it. Now, what type of reaction it is? Well, you notice that this is displacing this, and this is displacing this, so this is double displacement, exactly.
Oh, okay, I didn't see the little do after first.
Mhm. Yes, sir. 11.
Yes, sir. Yeah.
Okay, so in the case of 11, to balance this, let's see here, we have 1 sodium, we have 2 hydrogen. Oh, so what I'll do, I'll put a 2 here, and put a 2 here. And put a 2 here, right? So that's a balanced equation. And the type of reaction here is where the sodium displaces the hydrogen, right? So this is single displacement. All right?
So 2, 2, 1, 2.
Yeah, 2, 2, 1, 2, yeah. Well, I might as well, post the video.
What is chemistry right now?
Oh, it's fun. I mean, nothing explosive or anything like that. Don't want to risk anything like that, but I mean, it's basically you're learning in the lab, or you're seeing in the lab what is discussed in lecture, so I try to organize my lab so that it follows the topic that we cover in lecture, so.
Are you the one who does law?
I'm sorry?
Chemistry?
No, I don't know, you know what?
Is that on Calvin maybe?
Yeah, I know, Caps, I don't know if he still does it, but I know he was, he does a lot of online stuff.
Yeah, I just know, because one of my friends had it where they were able to use chemistry at the same time, so they did chemistry first and lab on the second semester. And so that's what they did on.
Yeah, I'm not a big fan of online unless The only way I'll be satisfied with the online labs is if they come up with, I don't know if you're familiar with Star Trek
Yeah,
and the hollow, the hollow,
all there,
holodeck that they have. If they can create something like that,
yeah.
yeah, you know what I'm saying? I would be for that, but otherwise, as far as I'm concerned, nothing beats actually being in the, the actual, physical lab. That's just my feeling. I mean, we have had, faculty, we have had discussions about this and people have different views. I guess I'm still old school in that regard.
I'm just trying to figure out, that because, lunch science is, on the F6. I think it's the dates is August.
Yeah.
I'm trying to keep plans with the USF.
Oh, okay,
And so, which I still need to do, chemistry, obviously, can't
Right.
do
right,
and then I also need to do a trig and calculus. Technically, I don't need to, but
right,
if I'm doing electrical engineering, it's good to build up the foundations best that I can.
Yep.
And and the plan is to just try to test out in like for class, test out on Spanish 1 and 2.
Oh, okay.
And humanities my second credit. And just because technically for USF's pathway, like kind of behind already.
Already?
Technically, they want you to start at Capricorn. And and then do your gen eds throughout the 4 years, not like how it is there.
right,
And like my advisor's like, well, if you stay at CF, save money. And it's like, if I stay at CF, it's all your pathways. I'm 2 years behind.
okay,
And because then it's 2 years here and then 4 years at USM.
well, let me ask you this, so, hold on, let me make sure that these guys know. Renfro is here. And Monte Mayor is here. Did anybody is coming late?
I came
What's your last name?
last stop.
Okay, I got you. And what's the name of the guy that you came in with?
David Alliance.
Davis? Oh, Elias, okay.
Yeah.
Anybody else came in late? No? Okay. Well, let me ask you this, do a lot of courses, like in your case, do a lot of courses that you do here, does it transfer over to, USF?
It should.
Because I know UF is very,
Well, so that's why I try to explain to my advisor that I still gotta get with USF Electrical Engineers Department. Cause technically, the ABET accreditation for electrical engineering, the first class is to be taught a specific way. So even if I do Cap 1 here, they could just throw it out. And she's like, well, I've never heard that before. It's like, okay, because she's like, well, we have engineers transferred to that program, like.
but doesn't course,
Yeah.
doesn't course itself. I mean,
Yeah, that's what
it's
it's just like, well, no one's come back and complained. It's like, well, if you're at USF, but you legally come back and talk to your senior
Right.
advisor and be like, oh, this is
I
nonsense.
see, I think. The advisors here. From what I hear, I mean, I've never interacted with them personally, but from what I hear from students, just talking to students. It seems as if a lot of advisors need to do some more research in terms of what.
Well, I know too, like I said, that she wasn't too happy when I was saying that because
Right.
it's been to USF. As a mid-level transfer.
Right.
Is technically too, the 2 year pathway.
Mhm.
For electrical engineering isn't part of the degree program for USF. So that really is saying like. This doesn't exactly transfer.
Yeah, because, from what I've heard, well, from what I've heard, not in engineering. But I've heard this from students trying to, and this is not USL. I've heard from students trying to get into medical school at UA,
Yeah,
right? Especially when I just got here, I haven't heard anything recently, but when I just got here, like, for the first 2 or 3 or 4 years I've been here, I hear students saying that, well, and in particular, organic chemistry, they're saying that organic chemistry here doesn't transfer to UA.
well, that's the thing is, so. I mean, one thing you definitely need to double, like, besides electrical engineering, you
Right.
gotta double check. That it says like, if it's 1147, it's 1147 over there.
Right,
And, so that's what I was double checking with the chemistry, it is, the 2045.
Right, 2045, 2046.
Yeah,
Election lab.
and and so that's what I was unsure if I should try. Cause I can test out a chemistry.
Hmm.
And then I would only be left with the lab I have to do, cause
Oh.
USF requires you to do lab no matter what. Even if you test out a chemistry. And so that's why I was like, well, I don't know. How difficult it would be to follow along lab if I'm not doing the chemistry class. And which I didn't even bring up the prep stuff to the advisor, because I knew she would be
Right.
happy about that either.
Right.
And it's just so like, these gen ed classes I'm doing. Are. Supposed to be spread out through the 4 years of USF,
Okay,
so the fact that I'm like doing them now. Is making it where technically I'm behind,
okay.
because you know, you can't skip, like, you can't do calc 1 and calc 2 at the same time.
Right,
So it's like. If they have a specific English, say like you do calc 1,
Hmm.
Spanish 1, and
Right.
chemistry. And you really good Spanish, then you know, you're
Yeah.
a light semester, you can't do anything about it. And so that's what it seems like it's gonna still, even with me transferring as quick as I'm gonna try. That it still will be like, I'll still have a light coursework for like the gen ed classes, cause the plan is to test out the exams course, the extra credit, social studies course. The American history course, and then maybe chemistry and the Spanish 1 and 2.
yeah, because
That's 5 courses that I would be able to skip.
I can say this, as far as, I'm not so sure about USF because I have not had any. Like personal information or communication with, USF in terms of chemistry courses. But, UCF, they have partnered with us. So much so that, they invite instructors from colleges like this college to meet with faculty over there
Yeah.
to make sure that we're all teaching, the same thing. So the chemistry course that we're teaching here is basically the same that will be taught in terms of the material and so on. In fact, I am the, I'm CF's representative, on, they call it the, curriculum alignment committee, that's what they call it. So I'm CF representation for chemistry in that committee. In fact, we have a meeting on Friday after Orlando. Because we meet every semester, basically to discuss, what should be, make sure that everything is in agreement so that when a student transfer from here to UCF, basically they would come there, basically having a background which will be similar to students who were at UCF doing the same course. That's it. But I know UF, for some reason, UF has no interest in having that kind of collaboration. That hasn't been the case since
Well, so that's another thing with the USF transfer electrical is like, so even the advisor was like, technically, if you do the 2 years, like, you're guaranteed. Transfer somewhere, but you're not, but she's like, you're guaranteed to a university, but not USF specifically. Like, they can still deny you, you're just guaranteed at least one of them.
But even if you're guaranteed a transfer, that doesn't mean that all the courses necessarily would be.
Exact, that's why it's like,
That's that's the issue I would have with that, and that's why.
that's why I contacted USF.
Uh-huh.
And they're gonna give me a call back when they talk to the electrical.
Right, yeah.
department.
Well, you see, my thing is, you should have to do that. The,
Well,
advisors,
yeah, exactly.
I mean, from what, you're not the first person, no, you're the first person from engineering that I've heard about that, but most of the students that I've talked to were like, they're trying to get into medicine, pharmacy, whatever, and they all tell me the same thing, especially when it comes to the organic chemistry courses.
Well, that was another thing too, I was like, how many electrical engineers are actually talking to, like, people wanting to go to electrical engineering?
Right.
How many are actually talking, because I know at least at USF, when I was at a graduation, there was 4 electrical engineers graduating.
Oh.
So if there's only 4, in that, whole time, tell like realistically how many are actually coming from CF. And I think the thing is with CF, the problem is the like the associated arts engineering.
Mm.
You know, you can go and get your certificates for like automation and all that, where it's not actually like engineering.
Oh, okay.
And then two, electrical engineering is still different from like if they, because most people are not gonna wanna do that. Electrical engineering, just because it's jack of all trades, so you get to touch base in all the engineering degrees except for nuclear physicists.
Mhm.
So a lot of people are gonna avoid it, it's like, well, you have to have one, two.
But I thought that, well, some of them, I thought civil is like the most popular. Is it civil? Is the most popular engineering?
Yes, because you're dealing with physical.
A lot of physics.
Yeah.
Right.
Where electrical engineering, you do physics and theoretical physics,
Okay.
differential equations, signals and frequencies. So you're like touching upon everything. And that's actually, if you look at the job statistics of electrical engineers, graduates from college, only 5% are actually in electrical engineering jobs. Because technically they're going and taking the chem jobs, the civil engineering jobs, the
Okay.
industrial engineering jobs. Because again, it's jack of all trades, so you can just go do whatever you want. And that's what, even if you go to like the electric companies, even though technically there would be like, that would be civil engineering, the people they have hired are electrical workers.
Yeah,
Like, that's the thing is I've dived deep into it, and it's
Right,
like,
right, right.
I don't wanna get.
you know, on a slightly different topic, so, the STEM club, we're planning on having a panel discussion of different people. In, different, STEM careers,
Yeah,
so. I'm trying to find different people, I'm planning on consulting the math people to see if I can get somebody who, some data scientists. I'm gonna see if I can get a forensic scientist.
yeah.
So I need to call like the sheriff department to see if they can put me onto somebody. I probably need to call the engineering folks here to see if they can put me onto somebody who's an engineering person.
Yeah.
There's one past student I'm planning on having, I'm calling. He's now in grad school at USF physics.
Okay.
So. The tentative date for that would be the 20th of April, but. I haven't got the names yet, and plus, you know, people have their own schedules, so I don't know who can make it to be a part of that, kind of. Yes, sir.
Number four.
Hold on. Number,
Four in section B, that's a combustion reaction, right?
number 4 in section B. Or section B, sorry.
Yeah, section B, number 4,
Yeah.
that's combustion,
Mm-hmm.
okay.
Yep. That would definitely be burning anything in here,
Okay,
anything
okay.
is combustion.
The plan is too, I gotta check what the requirements are, but since electrical engineering does so. Math heavy,
Right.
I think I should be able to, as 1 or 2 courses extra, I should be able to get a math minor too.
Oh, okay.
Doesn't really benefit job aspects for electrical engineering, but it's like, you know, half the paper anyways,
Yeah.
why not?
Yep.
So, it already has.
But yeah, from what I've heard, and this is like I said, only in relation to what students tell me. It seems as if a lot of the advisors need to do their research in terms of, well, especially in terms of what courses will transfer, because I think that's where most students are having issues.
Well, even with like financial aid too, since I got here, I did professional judgment, okay? So that's the 6th of January, I did professional judgment. And I left most bills on financial aid, tell them to call me back, gave us my student ID, all that. And finally got with my advisor this last week. And she's like, well, they're saying you only emailed them once. It's like, okay, but if I emailed them once, then why have I, so you guys, missed, you still got the email from. So why haven't I got a response to the girl? It's as of right now. It's all good.
Yeah, what I'm gonna do is scan them and send them to you, via email.
Okay. Awesome.
So, I should get them graded by this weekend.
Okay.
One of the things that's gonna slow me up is that I have to drive to Orlando for a meeting on time. But, I'm gonna try to get them done by this weekend, so I would say look out for the email, either Saturday or Sunday. More than
Okay.
likely it's gonna be Sunday, to be perfectly honest, so.
Thank you so much.
Yeah, no
I
problem.
appreciate it.
Mhm.
Have a good day.
You too.
I know for sure I struggle on that test.
Oh, really?
Yeah,
Well, we'll see,
So
we'll see.
hydrogen. That would just.
What's up?
So I send you my, I think first time assignment from PDF. I didn't still PDF.
Oh, okay.
Last Tuesday.
Oh,
So
yes.
we got them.
I
Well,
don't
even
know.
if we get them in PDF, so I don't know.
Yeah, I
Either
don't,
resend them out, resend them.
yeah, I'll have to look at, when did you send them?
Tuesday, last Tuesday.
Okay, what I like, that means I got them, I've been getting a lot of emails from
Yeah.
that type, so I don't remember, you know, specifically yours.
I'm not worried here.
Alright, yeah,
What do you do?
well,
So, have a good day.
yeah, you too. You guys have any questions?
I think so. Got 2 questions left, I think we'll be fine.
You know.
Alright, let me pack up